Hey everyone, Dan here again. I bet you didn't expect to hear from me again so soon. But we're back again, looking at balancing redox reactions, this time in basic media. Good news is, if you watched the last video on balancing redox reactions in acidic media, the process is pretty much the same, with just a little bit extra at the end. Alright, so the reaction we're looking to balance is here. Notice again we're in the same kind of predicament that we had in the last problem, where atoms are seemingly just appearing out of nowhere or disappearing. In this case, notice that we have oxygen appearing out of nowhere on the product side, and we didn't have any in the reactants. So we're going to again use the half reaction method to balance this time with 10 easy steps. So they're extra 3 on top of the acidic. But the first 7 steps are exactly the same. So I'm going to go pretty quickly through the first 7. It's just review from the last video. So if you missed that one, go back and take a look at the acidic media problem right before this. Alright, so again, the steps are going to be to write out your half reactions. So we break this down into a silver half reaction and a zinc half reaction. The second step will be to balance our non-hydrogen oxygen atoms. In this case, again, this is kind of a nice problem where only one thing needed balancing. So I introduced this coefficient of 2 to balance out the silver, and zinc was already balanced. Alright, so now we will balance the oxygen atoms by adding water. In this case, we only needed to add a single water molecule to balance out this oxygen that we have in the silver oxide. And we didn't need to add any to the zinc half reaction. The fourth step is going to be to balance out the hydrogens that we've introduced in the previous step by adding in water. So I added 1 water molecule that came with 2 hydrogens attached to that oxygen that I was really looking for, and so I'm going to add 2 hydrogen ions to the product side to balance that out. The next step is going to be to balance the charge by adding electrons. So in this case, we had neutral species on the reactant side, and overall a positive true charge on the product side. So I'm going to add in 2 electrons on the product side to the first half reaction, and in the second one, notice I have a +2 charge on the reactant side and a neutral charge over on the product side. So I'm going to add my 2 electrons over on the reactant side for this one. So if I rewrite those, in order to balance those charge, I've added 2 electrons on the product side to the first half reaction and 2 electrons on the reactant side in the second half reaction. Alright, so we have charge balance. Now we want to make the electrons lost equal electrons gained. In this case, it just happens to work out that we have 2 electrons in both the first half reaction and the second half reaction, so we actually don't have to do anything here, which is kind of nice. And then what would have been the final step in the acidic media, in an acidic media problem, is to just simply add those 2 half reactions back together. So in this case, the only thing that cancels out are those 2 electrons. So we have 2 electrons here and here on the reactant and product sides, respectively. When we add those together, those cancel out. And then we combine everything that's on the reactant side, write it down here. Everything that's on the product side left over, write it down here. And this would be our balanced reaction in acidic media. And so the final 3 steps are going to be essentially converting this balanced reaction in acidic media into a balanced reaction in basic media. So if we're talking about acidic media, we're saying there's an excess of hydrogen ions in solution. Basic media would be an excess of hydroxide ions. So we want to get rid of these H+ ions and cancel them out with hydroxide ions. So that's going to be our 8th step. And what we're going to do is just add in enough hydroxide ions to effectively neutralize the H+ that's already present there. So we're going to take, if we have 2 H+ over here, we want to neutralize that with 2 hydroxides, and whatever we add to this side, we have to add to this side. The next step is going to be to essentially allow that H plus and OH minus to react to form water. In this case, if I have 2 hydrogen ions and 2 hydroxide ions, those will react to form 2 water molecules. So I've gone from having 2 H plus and 2 OH minus to just 2 H2O on the product side. And then everything else we're just going to bring down. So everything on the reactant side we bring down, and then everything that didn't react there we're going to bring down on the product side. Alright, so the final step, just like in the acidic media problem, is going to be to combine like terms and cancel things that appear on both the reactant side and the product side. So in this case, notice that when I formed those 2 water molecules on the product side, I actually already had water present on the reactant side. So one of the water molecules here will cancel out with the water molecule over here, and then we wind up with just a single water molecule on the product side and no water on the reactant side. Once we cancel everything out that appears on both sides, then it's just a matter of, again, taking everything that's left over, bring it down, everything that's left over, bring it down, and then what we're left with is the balanced reaction, but this time in basic media. So, to again go over each one of those steps, notice that the first 7 are exactly the same as an acidic media problem. So again, in a sense, you almost don't even have to think about it. If you just follow these 7 steps, regardless of what problem you're being asked to do, you'll wind up with a balanced reaction in acidic media. Then if you go back and read the problem and it turns out they were asking for basic media, then the final things that you want to do are to balance H plus by adding OH minus and combining the H plus and OH minus ions as long as they're on the same side to form water, and then make sure that any water that you do form, if you had water present on the reactant side or the product side, make sure that you cancel out water if it appears on both sides. And that is really it. So again, if you follow these steps, you really can't go wrong. But if you do have any questions, feel free to come to office hours, send any of us an email, and I will catch you in the next one. Thanks, everyone.